Welcome back, students. So in this video we'll be finishing off with exercise 1.3. So this is what we have. Okay, we have to prove that 2 plus root 3 is irrational. Again, we proved this in the same method that we have done earlier. So let us assume, that 2 plus root 3 is rational. Okay, so if it is rational, that means 2 plus root 3 can be written as a by b, right, where a and b both belongs to a set of integers. So I'll be taking this as, it's very simple proof, a by b. If you take 2 to the right hand side, you get this minus 2. So you can take the LCM, you take, so a minus 2b. Alright, now if you clearly look at this, we have this given statement that a and b belongs to an integer. So a and b can take any values as long as it's an integer. So it can take 0, plus, minus 1, plus, minus 2, and so forth. And if you've watched my previous videos, I've given an explanation of what values you can take for a and b. Okay, so you just watch that, okay, and then you'll have a better clue. Therefore, we can know that a by 2b, a minus 2b, b is a rational number. Okay, it is a rational number. Clear? Now, since this is a rational number, okay, and a minus 2b by b is equal to root 3, that means root 3 must also be a rational number, right? Therefore, root 3 must also be a rational number. This must be a rational number, okay, because we understood that a minus 2b by b is equal to root 3 and a minus 2b by b is a rational number. So it must be a rational number, but we know, okay, we know that root 3 is not rational, right? We know that root 3 is not a rational number, okay, rational number, all right, because see, even if you were to take root 3, okay, if you were to take in p by q form, a rational number is usually in the p by q form where both p and q are integers, but over here 1 is an integer, okay, that means q, okay, in the sense 1 is an integer, but root 3 is not an integer. All right, so since root 3 is not an integer, that means this 3 by 1 cannot be a rational number. It is rather an irrational number. Therefore, our assumption is wrong, okay, our assumption is wrong. So the assumption that we have taken is that 2 plus root 3 is rational, right? We have taken this 2 plus root 3 is rational. We have taken that, our assumption is wrong, so obviously we have to say that 2 plus root 3 is an irrational number. Clear? It's just as the same as the previous questions. The last question we have for this is given. We have to prove that 2 plus 3 by root 2 is irrational. So let's say, so proof, okay. Now let us assume, okay, first let us assume that root 2 plus 3 by root 2 is rational, okay. So since this is rational, we can say that 2 plus 3 by root 2 is going to be equal to a by b, where both a comma b belongs to an integer, okay. You just take the LCM for this, so you'll be getting this as root 2 into root 2 plus 3 by root 2 equal to a by b, alright. So root 2 into root 2 gives you 2 plus 3 root 2 equal to a by b, okay. So, okay, root 2 into root 2 gives you 2, okay. See, root 2 into root 2 basically means root 2 whole thing square, right? So you can always cancel out the square and you end up getting 2, or if for some of you maybe you're more confident with this, root 2 into root 2 basically means 2 into 2, which is 2 square, right? So you can always cancel out the square, so you're left with 2. Clear? So you're left with 5 by root 2 equal to a by b, okay. So in the next step, I'll take 5 towards this side, okay. So you'll be left with 1 by root 2 equal to a by 5 of b, okay. So let's just reverse it. Clear? So when you reverse that, you can write this as root 2. So this will become 5b will become the numerator and a will become the numerator. Now here, since both a and b are integers, okay, since they are both integers, it goes to say that 5b by a is also, or is a rational number. Okay, it's a rational number. Clear? It's a rational number, right? Because you substitute any value you want for a. You can put a as 0 or b as -1, or take b as 2 and a as -2. Whatever you take, you'll be getting some sort of numbers, and this numerator will also be an integer and your a will also be an integer. Okay, clear? Remember, a and b are integers, okay, because we have assumed that root 2 plus 3 by 2 is a rational number, and because it's a rational number here, a and b must be an integer. So do not make the mistake of substituting a as root 2 on all of that. It will not be correct, okay, because we have already said that a and b are integers, so you can only put integer values, okay. So it's also so finally you have that 5b is a rational number. That means if this is a rational number, okay, then obviously since 5b by a is equal to root 2, that means root 2 must also, therefore, hence root 2 must also be a rational number, right? Must also be a rational number. But we know that this is not true, right? We know that this is a contradiction, right? Contradiction as root 2 is irrational. Okay, it's an irrational number. All right, irrational number. Hence, our assumption is wrong, and our assumption is wrong. Assumption is wrong. Okay, and what was our assumption? We go back. Our assumption was, we assumed that root 2 plus 3 by root 2 is rational. Now, since this assumption is wrong, we just have to conclude saying that root 2 plus 3 by root 2 is irrational. Since our assumption is wrong, we have to conclude this way, okay? Hence proved. Okay? Alright. So we shall end the video here.